Okay, let's start video number 2 on bonding. You may recall in video 1, we talked about covalent bonding, like an ionic bond, covalent bond, and then the coordinate covalent, that is the more polar covalent bond, correct? So I was just going to go share the screen so that we can see what we are talking about. This will be I'll try to make it, as I'm trying to make this video as meaningful as possible. That way you get it soon rather than take a long time, etc. Anyway, let's start off. So this is where we did last time. This is a bonding. We talked about how if electrons are completely transferred from one atom to the other, it leads to a battery type situation, which is an ionic bond. There is no real line between them. And then we went over to covalent bond where the atoms are identical, in which case there is no transfer of electrons from one to the other, but they're shared. And it's shared, it's a covalent bond. And when the sharing is not equal, as in oxygen and hydrogen and oxygen, so it's unequal because oxygen is more electronegative, so it pulls the electron density away from the hydrogen, leading to something called a delta negative, negative charge on the oxygen, and the positive charge on the hydrogen, but it's still covalent. It's not a complete transfer. So that's where we left off. So obviously there are some very major simplifications here, especially in the valence of oxygen. I will come to that in a second in this video. In this video, we have to talk about formal charge. What the hell is that? It's very important, right? When we say acetylene, CH, C triple bond CH, what is the formal charge? There is no formal charge, it's 0, right? But if this breaks as a proton, we say C triple bond C minus plus H plus, right? Like an acid base thingy. There's a charge here. So where is that coming from? So many students are highly confused about this. I just memorize it and move on. But I just want to go back into the little bit of basics to understand before we get to here, and then how it polymerizes using Ziegler-Natta. We want to get back to basics, okay? So the last class we left off at hydrogen and oxygen, right? And we know that there's something wrong about what was, there's something too simplistic the way I explained it. What is the what is the number of valence electrons in oxygen? Anybody? Obviously, this is a Zoom, so nobody is attending, nobody can respond. So I'll just imagine some of you responded, right? All right, here's the periodic table. Hydrogen is 1, helium is 2, yada yada. Lithium has 3 electrons, beryllium is 4, boron 5, carbon 6, nitrogen 7, oxygen 8. The number of valence in oxygen is only 6 because there are 8 electrons total, but that's in the first shell. Hydrogen and helium shell has to be deleted. So it's only 6, right? In the valence, in the number 2 shell, there are only 6 electrons. So all right, so 6 electrons. So let's take a look at it. 6, right? How do you draw it? 1, 2, 3, 4, 5, 6 electrons, correct? So you got to need an octet. They need 8 electrons, right? Around oxygen. I mean, how? How are you going to achieve that? There 2 ways, right? So if you look at, if you have a hydrogen coming from this side, another hydrogen coming from this side, right? Suppose you had that trying to bond with the oxygen, leading to hydrogen. Something like this. So you have your octet, right? For oxygen satisfied, all the 8 electrons, right? What about the hydrogen? The hydrogen has 2 electrons, right? 2 and 2 around it, satisfied, right? So it's okay. So this is how water molecules form, right? We will talk about why this is the actual geometry of water molecule is actually bent. It's not straight like this. And it's not Okay, this is incorrect. Okay, and why that should be, etc., etc. Okay, so let's go back to here. So what is the formal charge? So this is 1, right? What is the formal charge on oxygen in water? What is the charge on this? Obviously, water is neutral, right? So it's 0. But how do we know it is 0? So formal charge is equal to what? Number of valence electrons minus number of lone pair electrons minus half the number of bonded electrons. Okay. So let's take a look at this formula. For oxygen, the number of valence electrons is what? 6, right? We just went over that. How many lone pair electrons? Lone pair is these 1, 2, 3, 4, right? 4 electrons minus half the number of bonded electrons. These are the bonded electrons, right? 1, 2, 3, 4. That's 4. So that's a total of a good number of 0, right? That's why the formal charge on oxygen and water is 0. So let's take a look at this. How about base, right? What is base? Hydroxide. Remember, that's a base. So how would you get this? So water, right? How do you get base from there? What the hell is a base, right? How do you get that negative charge? -1, right? So how does it get that formal charge of -1 in hydroxide? So again, if this is broken this way, right? If this cleaves, so these 2 electrons remain on the oxygen, right? So that'd be 1, 2, 3, 4, 5, 6, and this one is 7 and 8, right? Plus the hydrogen is gone, right? This cleaves. So now what's the formal charge on the oxygen, right? So that's 6. Formal charge is 6. So how many? 1, 2, 3, 4, 5, 6, right? So 6 right here minus 6 minus half of this 2, right? Which is -1. Voila, right? This is the -1 that we have when we say OH minus is a base. That's where the -1 comes from, okay? The funny part is that there are 2 kinds of cleavages. Homolytic versus heterolytic bond cleavage. What is this? What is this crap, right? If the bond breaks the way we said, where both the electrons are moving this way, a full arrow means both electrons are taken off onto one side. This is called a heterolytic bond cleavage. Both the electrons, so I mean both these electrons move here, giving you this one, right? This both electrons have moved there. There's another way it can happen, right? Since every bond is 2 electrons, one can move this way, the other can move the other way. True sharing, right? So what will the product be? You get it with that electron, right? Plus the hydrogen comes off with its electron, right? So you have this original lone pair still there. So what is the formal charge on this beast? We don't know what do you even call that, right? It's not a base because there's no minus. So let's take a. So at least the way it's drawn, there's no charge on it, right? Is it really true that the formal charge on oxygen is nothing? Let's take a look. formal charge is 6 minus 1, 2, 3, 4, 4 minus half of this, right? I mean, well, there are 1, 2, 3, 4, 5. So there's 5, right? 1, 2, 3, 4, and 5 minus half of 2, right? Of these two electrons. These are the two. 0. So this is called a hydroxy radical, which does all the bleach in your house. Okay, hydroxy radical. Hydroxy radical formal charge is 0. The formal charge on all radical species is 0. Okay. With that, I'm going to stop this. Otherwise, it'll keep going on and on until kingdom come, right?